Hello and welcome. Today we're going to be doing a little bit of, we're just going to be doing examples of L'Hopital's rule. Okay, we're going to be doing examples of L'Hopital's problems. I want to explore a single function, and it's going to be, we're going to look at the function natural log of x all over the square root of x minus 1. Okay. And we're going to look at uh, two limits. Okay, so the limits we're going to look at are x going to infinity and x going to 1 from the positive side. Right, so we're going to do this together. So I do both of these together. So what I thought I would do is just examine, first of all, we know that natural log by itself is a function that it crosses at 1, it crosses the x-axis, and it goes up like that. We also know that a natural log, has a similar look. So the question then, of course, is which one is bigger in the long run? In fact, I should probably make some thing that we actually do know that the square root of x should actually go above at some point, like that. That should be how it looks. Okay, but one thing we do know is that if I look at square root of x, if I take its limit as x goes to infinity, we know that is infinity. And of course, we know that the natural log, the limit of x goes to infinity of natural log over x, natural log of x is going to be infinity as well. So now what I want to do, of course, is look at the limit as natural log of x all over the square root of x. We want to ask, what is that limit as x goes to infinity? All right, so what we see immediately is that we have an infinity over infinity type of situation. What that, of course, means, is that L'Hopital's rule is allowed. Which means, of course, we can take the limit of the numerator and denominator's derivatives, and it will equal the same as the original function. So the derivative of natural log, of course, is 1 over x, and the derivative of square root of x is going to be 1 over 2 root x. All right. So the limit here then, I can do a little simplification step now, which is I'm going to now take, it's going to be a 2 root x now goes in the numerator, and x goes in the denominator. One thing we can see here, just move this down here a little bit more. Maybe I'll move it all the way down here and just say that this is going to be limit as x goes to infinity. And we know that this is going to be x to the 1/2 over x to the 1. So that's going to be x to the negative 1/2. So we're going to get finally is 2 over root x coming out of this. Okay. Right, so in this particular case, now we have a 2 over infinity case. So L'Hopital's rule is not needed again. Okay, so what we can say then is that the limit is going to be 0. Okay, so what this means, it means, and what is the meaning of this? It means that basically that natural log of x goes much more slowly to infinity than root x. Okay, because basically what it means is that root x is just getting larger and larger and larger compared to natural log of x. Even though they're both getting larger and larger, root x is getting much, much larger than the natural log. And at some point, the ratio gets closer and closer and closer to 0. All right. Okay. Cool. So now what I want to do is we're going to, of course, go to another page. And now let's examine the next limit. Let's look at the limit as x goes to 1 from the positive side of natural log of x over root x. So we know that the limit of x goes to 1 from the positive side of natural log of x is going to be 0. And of course we know the limit x goes to 1 from the positive side of root x goes to 1. All right, so that means what we have here is a 0 over 1 type limit. And we know, so L'Hopital's rule does not apply. Okay, this is not an indeterminate form, so this one actually turns out to be 0. Okay. All right, so we can actually examine a few more limits. What if I talk about limit of x goes to 0 from the positive side of natural log of x over root x? Okay, so again, the limit as natural log of x as x goes to 0 from the positive side, that equals negative infinity. And the limit of x goes to 0 from the positive side of root x is just equal to 0. All right. So my indeterminate form is negative infinity over 0. That is not an indeterminate form. So no L'Hopital's rule as well. This thing goes to negative infinity. All right. So we've seen 2 cases here. What's really important for students then, of course, is to recognize when to use L'Hopital's rule and when not to. Okay, it's only for certain indeterminate forms. For determinate forms, negative infinity over 0, we know what the answer is. Okay, so now I want to talk about one more problem. Right, this is another L'Hopital's rule limit where we are going to use L'Hopital's rule. So let's modify root x. We're going to make it root x. Now it's going to be minus 1. All right, so now consider natural log of x over root x minus 1. And we're going to take the limit as x goes to 1 from the positive side. All right, so now we have a proper L'Hopital's rule appropriate problem, because we know that the limit as natural log of x goes to 0 from the 1 from the positive side. That's going to be 0, and we also have a limit as x goes to 1 from the positive side of root x minus 1, and that goes to 0 as well. All right. So that means we have a 0 over 0 indeterminate form. The L'Hopital's rule is okay to use. So then, of course, we're going to write our limit symbol as we always do. It's common to forget, but we're going to always remember. And that's going to be, 1 over 2 root x minus 1. All right, so there we go. There's our function. Now we're going to do a little bit of simplification. Limit as x goes to 1 from the positive side. And now we're going to get a 2 root x minus 1 all over 1 over x. Oh, oops, undo. I'm sorry, I meant to say over x. Okay, so in this particular case, what we have here then, of course, is still, let's look at what we have here. We have something going to 0 at the top, but going to 1 on the bottom. This is not indeterminate. Okay, it's not in a determinate form, so no LHR is going to be used now. Okay, and what we can do, of course, say is that this is going to be equal to 0. That is the limit. All right, so this is, again, what we see here is that root x minus 1 goes more slowly to 0 than natural log of x. Natural log of x is sort of dominating as you're getting to 0. All right, so the tables of turn in this particular case, we have the opposite outcome for our L'Hopital's limit as we did from the x going to infinity case of square root of x. All right, so I hope this is useful. And what I really want to see on your final exams or any exam or any work is I want to see this good analysis. I want to see you making these sort of identifications. I really want to see everyone identifying the type of indeterminate form it is and telling me if L'Hopital's rule is okay, but also identifying when something is not appropriate for the L'Hopital's rule, when you can proceed with some other technique. All right, so I hope that's helpful. Thank you very much, and I'll see you next time.